Notes 11.4, finding the area of regular polygons. Okay, so to find the area of regular polygons, we're going to need to divide it up into something that we're used to. Looking at the 4 regular polygons on the screen, what do you notice we could divide each one up into? As you can see, I'm dividing it up into triangles. And every regular polygon, you can divide it up into congruent triangles. If you have a 3-sided figure, you'll make 3 triangles. 4-sided, 4-sided triangle. So then what do we need to think about? We need the base and height of each triangle, and then we're going to multiply by how many triangles there is in each one of the figures. All right, let's do some vocabulary. As you notice, each of those regular polygons had a center to it. The center is the center of the circumscribed circle about the regular polygon. That means the circle is outside of the regular polygon. All right, next word is radius. The radius is going to be the length of the segment from the center to a vertice of the regular polygon. All right, next word, central angle. You should recognize that from the circle chapter. That's going to be the angle formed between 2 radii drawn in the regular polygon. That's going to be an important angle that we're going to need to know to either do 30, 60, 90, 45, 45, 90, or if you need to use trigonometry to solve in the regular polygon. Next vocab word is apothem. The apothem is the height of the congruent triangles that is drawn inside of the regular polygon. So it's very important. It's the height. All right, now for the formula of how to find every regular polygon's area. It's going to be 1/2 ASN. So let's see what they mean. N means the number of sides, because that'll be how many triangles that we have. The S is going to stand for the side length of each triangle, which is the base of each of the triangles. And then A is going to stand for the length of the apothem. That's going to be the same formula as 1/2 A times P, where P is the perimeter. So for every single problem, I want you to start off by labeling A, S, and N. Fill in any information you know. We know that N is 3 because there's 3 sides. We know the side length is 6. Now, since we have an equilateral triangle, the base angle is 60. So that means inside of this larger triangle, we have a 30, 60, 90, since the 30 is half of the base angle. So if half the side is 3, the apothem is going to be radical 3. So to find the area, we're going to do 1/2 ASN. So that's 1/2 times 6 times 3 times radical 3. So use some mental math. And you know that the answer is 9 radical 3 centimeters squared. Pause the video right now and try to find the area of the square. Okay, now for the square. Remember, every time label your A, S, and N. We know that a square has 4 sides, so N is going to be 4. And we know that a square has 90-degree angles. So when we make these triangles inside, we have 45, 45, 90 right triangles. So that means the apothem and half the side length are both 6 radical 2. So the whole side length is going to be 12 radical 2. So now we're going to use our area formula. We're going to do 1/2 ASN. So that's going to be area equals 1/2 6 radical 2 times 12 radical 2 times 4. Use some mental math. And you're going to end up having an answer of 288 inches squared. By the way, today's magic word is cylinder. Now we're going to try a pentagon and a hexagon. Go on ahead and pause the video and try the problems yourself. With the hexagon, we've got ASN just like normal. We know that N is 6. We know that S is 18. Remembering our formula to how to find the interior angle of a hexagon, you're going to do 180 times N minus 2 divided by N to find out that it's 120 degrees. So the base angle is 60. We have a 30, 60, 90 right triangle. So the apothem is 9 radical 3. Use our area formula. 1/2 9 radical 3 times 18 times 6. Using some mental math, we get 486 radical 3 millimeters squared. Now, as we move on to the pentagon, something you need to remember using our formula is that it doesn't have a nice angle for us to use. It's not 30, not 60, not 120, 45, 90. It's 108 degrees. So we mark out our N and our S. We're going to use a Pythagorean triple to know that our apothem is 9. 9, 12, 15 right triangle. So our area is 1/2 ASN, 1/2 9 times 5 times 24. And our area is going to be 540 centimeters squared.